Hey everyone, Mr. Allen here. Fairly informal video this time. I basically just want to look at duplication and how it affects our permutations. So I've simply made a list here of a regular 3p3 situation. We have the letters A, B, C, and of course they can be permuted across all the different positions. And so there are 6 different possible permutations of A, B, C, so no duplication. Now I've basically just copied and pasted this and changed all the B's to A's, slightly different colors so that they stand out a little bit. But we should be able to see then that this AAC, with that B having been changed, is the same as this AAC. They were clearly different on the previous case because it was a B. Now it's because it's two A's, they are the same. And then this ACA and this ACA are also the same. And the CAA here and the CAA here are also the same. So now by having two the same, we've essentially lost half of our options. So we have half as many options as we did before. Now I've basically done the same thing here, copied and pasted this group and changed all the C's to be green A's. And I think it's pretty obvious now that each and every one of these is the same. And so we have lost, we now have 1/6 as many different permutations as we had originally. There were 6 here, down to 3 here. I guess I could do a little cross out. That one's already been taken. That one's already been taken. That one's already been taken. So we're down to 3 here. So the original 6 divided by the 2. And now this time we're down to really only one possibility. And so we have 1/6 of what we had before. Or again, the original 6 divided by 6, or divided by 3 factorial in this case. So look at a couple of bigger examples. Here I've got my original list, no duplicates. On a 4p4, there are 24 possibilities. And just kind of scrolling down, you may not be able to see, but they are all different. Essentially what I did actually was I took my original list of ABCs, and then I put all the D's on the end. I took that same list of ABCs and put all the D's in column 3, then all the D's in column 2, then all the D's in column 1 to ensure that they were guaranteed to be different. So there are 24 different permutations in this no duplication column. Now, same sort of idea. When I end up with 2 the same, I've changed all my B's to darker A's. You can zoom this in a little bit. And basically I end up with AACD here and another AACD. I have an ACAD and another ACAD, CAAD and another CAAD. So once again, in this first grouping, half of my options have disappeared, or half of my different values have disappeared. I'm down from 6 in this grouping to 3. And if I go through each of the next groupings of 3, we see the same thing. AADC with an AADC, ACDA, ACDA, CATA, CATA. And so once again, by having 2 the same, we end up with half as many options in the end. So 24 divided by 2. Again, though, really it's 24 divided by 2 factorial, which we'll see as we look at these next few. So in this case, I have 3 of my objects being the same. I see AAD, I've already got an 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 AAD. So essentially, out of this first group of 6, I've eliminated 5 of them. I'm down to 1/6 as many. And then we see the same sort of thing, AADA. Well, that's new. Oh, but wait a minute. Same thing, same thing, same thing, all the way through here. So in each group of 6, again, I'm down to 1/6 of the original group. And so this again is 24 divided by 6, or divided by that 3 factorial. I'm left with 1 here, 1 here. I would have the 1 where D is in the second column, and 1 where D is in the first column. So I'm down to 4 different values here, 24 divided by, again, 3 factorial. And of course, if all 4 are the same, then I really only have the 1 option. So I'm eliminating all 23 of the rest. So from 24 down to 1, I've gone 24 divided by 24, or again, 24 divided by 4 factorial to get down to the one different option. 5p5, there are 120 possibilities. I'm not going through all of them here, but we have the same basic idea. I've taken all of my list of 24 and just put the e's on the end column. And so here I've got 24 different spots where E is in column 5. I have 24 different possibilities where E is in column 4, 24, 24, 24, 24. So 120 possibilities altogether. As soon as two of them are the same, we start to eliminate the two AACDs. I have ACADE. And again, my original group of 6 here now is down to 3. This group of 6 again, AA, DCE, and so on. Hopefully you're getting the idea now that, oh, I blew that. I've now got, again, half as many, so I'm dividing by 2 factorial and continuing to divide by 3 factorial here and divide by 4 factorial here. So hopefully that just kind of illustrates it a little bit better. In my original case, there were 6 possibilities. Then I was down to 3 possibilities here, which again is 6 divided by the 2 factorial, and down to 1 possibility here, which is the 6 divided by the 3 factorial. Similarly here, I have 24 possibilities. Here I have 24 divided by 2 because half of my possibilities are disappearing. So 24 divided by 2 factorial, which is 12. 24 divided by the 6 factorial, I'm down to only 4 unique possibilities with this one. And then here, of course, I have only the one different possibility. So it's 24 divided by 4 factorial. So hopefully just kind of seeing that, if at the very least justifies to you that the math works by taking my original list as if there were no duplication and then dividing by each of the duplicates moving forward. And although there is an example here, if I happen to have 2 the same and 2 others the same, so AACC, we would divide by the original 2 factorial and then divide by 2 factorial again. In the group of 5, if we had AACCC, the 120 would be divided by the 2 factorial and divided by the 3 factorial to end up with, what would that be, 10 possibilities at that point.